Yes. Bhavna, able to hear me?
Yes, sir.
Ashita, is
Yes,
there?
sir. Yes,
Okay.
sir.
All right. So, do you want me to repeat anything from the morning class, or should I continue with the class? All right. This is an extra class, so we can do. If you want, you can repeat something. If you want me to repeat. All right. Should I go ahead?
Yes, sir.
Vignesh, says- Vignesh,
Yes, sir.
were you there in the morning?
No, sir.
Okay. Then, could you attend the recorded session?
Yeah, sir. I will attend the classes by tomorrow, sir.
Okay. 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 You could not attend by now, no?
Yeah, sir.
Okay. You didn't get time, perhaps. All right. Okay. So, let's say there is a table on which there is a row. Mass M and length L. Mass M naught, length L naught, and X naught is hanging. I have to find the acceleration of rope the moment I release the rope. This table is frictionless. Because of the gravitational pull here, this will get accelerated. So this force will accelerate this mass, total mass. All I have to do is find the total force on this one, divided by mass will give me acceleration. So force on this part will be m into g. M is nothing but lambda into x naught, mx naught into g. So lambda naught into x naught into g. Lambda naught is nothing but m naught by L naught into x naught into g. I get the force on the hanging part. So acceleration will be equal to this F by total mass m. So that would be x naught g by L is the acceleration of the total mass. All right. Do you all get it? What I did?
No, sir. Sir,
Okay.
can you repeat also?
Yeah. Bhavna, do you have any doubts in the morning class? Because you were not interacting in the morning because of network issue.
Yes, sir.
So you don't have any doubts, right?
No, sir.
Okay. No, if at all you have doubts, please ask. Ashrita, Bhavna, other names I don't see who are here. Bhaskar is here. Pavani is here. Sorry, Pavana. Lakshmi. All right. So what I'm doing over here is I'm finding the force on this one. That force by total mass will give me acceleration. How do I find the mass on the force on this one? M into G. Gravitational force is mg. What is m now? M is lambda into x naught. Because lambda is my linear mass density. Linear mass density into length will give me mass of that length. Mass of that length into G is the force on that. That divided by total mass is my acceleration. So mx naught g by m and L naught by m. M gets cancelled out. I'll get x naught g by L naught as my acceleration. All right. So if x naught is 0, no acceleration. Whole of the mass is on the top. But if x naught is equal to L, that means whole of the string is hanging, then I have acceleration as g. Makes sense. But if only x naught is hanging, L naught minus x naught is on top. So acceleration will be x naught into g by L. All right. That's what the equation says. But
Yes,
now,
sir.
is it clear now?
Yes, sir.
Okay. Now, same thing, scenario is same, but the rope is not of constant mass. Mass is not given, length is given, and linear mass density is given. The variation is given. How it varies is lambda naught into e power minus x by L naught. Right, and x is measured from here. All I have to do is find the mass of this into G. Will give me total force on this rope, downward force. That divided by total mass will give me. So how do I do? I chop this vertical part into infinitesimal number of infinitesimal pieces. Mass of this would be lambda of x into dx. Lambda of x into dx. This is my dm. So force will be equal to Vf is equal to into G. For force, I integrate this from 0 to x naught. I get the mass of this one, force on the hanging part. Now this should be equal to total mass into acceleration. How will I get the total mass? Lambda of x dx from 0 to L naught into acceleration. Do you understand this equation? After this equation is just simple math. Not simple math, but it's math. Just math. Do you understand this equation? Force is equal to mass into acceleration. F is equal to total mass into acceleration. But how do you get the force? Mass hanging into G. How much is the mass hanging? Lambda x dx from 0 to x naught is hanging. But how much is the total mass? 0 to L naught. I integrate this from 0 to L naught to get the total mass. Into A naught is my acceleration. I'll get A naught as this by this. Do you understand this equation?
Yes, sir.
Any doubt in this equation? Others? Okay, now let's plug in the value of lambda of x. So I get lambda naught into e power minus x by L naught. Lambda naught into e power minus x by L naught dx. So lambda naught gets cancelled out. So I'll have A is equal to integral 0 to x naught e power minus x by L naught dx by integral 0 to L naught e power minus x by L naught dx into G. I integrate the above expression. Numerator, I'll get e power minus x by L naught by minus 1 by L naught by under limits 0 to x naught by e power minus x by L naught by minus 1 by L naught under limits 0 to L naught. Minus 1 by L naught, minus 1 by L naught gets cancelled out. What I now get is I substitute x naught and 0. So when I substitute x naught, I'll get minus x naught by L naught minus 1 by e power minus x naught by L naught by L naught minus 1.
Minus 1.
Right. So what do I get? I get 1 by e minus 1, e power this one. So I can write this as 1 minus e power minus x naught by L naught by 1 minus 1 by e into G. You get this?
The last step, don't understand.
From here, this one I substitute the limits. After substituting,
Yes,
I took minus
next
common
one.
numerator and denominator. I took minus common, minus 1 common. So minus 1 common తీసుకుంటే 1 minus ఇది అయిపోయింది. Minus 1 కింద common తీసుకుంటే 1 minus ఇది అయిపోయింది. Minus 1 got cancelled.
So
Okay.
1 by వచ్చింది sir. 1 by 2.
ఇది e power minus L naught by L naught కదా. సో e పవర్ మైనస్ 1
సార్
అవుతుంది ఇది.
ఇక్కడ సార్ నెక్స్ట్
ఎల్ నాట్ బై ఎల్ నాట్ ఉంది కదా, ఎల్ నాట్ బై ఎల్ నాట్ e పవర్ మైనస్ 1 అవుతుంది. వాట్ ఈస్ e పవర్ మైనస్ 1? 1 బై e.
ఎస్ సార్
ఓకే.
ఎస్ సార్
All right, so I got the acceleration. Okay. Hmm. Okay, can I erase it? I give you some homework. All right. Could you do the 10-minute exercise after the class in the lunch hour or sometime? Could you do? Could you get time?
No, sir.
You couldn't get time? All right. Others, you didn't get time? So when will you do then? If you haven't done till now, when will you do?
Sir, today.
Today.
Okay. Okay. Anyways, not a problem. Now look at this. I've got all right, I'll solve the homework problem. All right, because you haven't done. I'll solve the homework problem now. I have a rope. ఇక్కడ thick ఉంది, ఇక్కడ thin ఉంది. Morning I've done a problem when I applied force on left. That means the thicker end I have applied. But now I will apply at the thinner end. I have to find the tension in the string. All right. So lambda naught into e power minus x by L naught is how lambda is varying. Lambda of x from this side. But my force is applied at that side. So all I have to do is section this at a distance x from. I want to plot as a function of x. Let's say I section it at a distance x here. I want tension as a function of x. And this is on a horizontal surface. When I section it like this, I draw the FBD of two parts, FBD and MAD. This is T, action reaction pair. I told you always think of action reaction pair in pairs. This is acceleration A naught, and F naught is applied over here. And lambda is varying from here, and this is at the distance of x. Okay. How will I get acceleration? Net force by total mass, F by total mass. That's fine. But how will I get tension in the string? T is equal to this mx times A naught. All I'm doing is I've drawn FBD, MAD, and writing F is equal to MA for that. I've drawn the FBD, required FBD. Normal reaction draw cheyaledu because that's not coming into picture. MG draw cheyaledu because that's not coming into picture. But acceleration also I've drawn. So mass acceleration diagram is complete, free body diagram is complete. All I have to write is force is equal to mass into acceleration. Or a normal reaction would AL actually, but I'm not drawing it for no, it is getting congested. So mass into acceleration ante so what is mass of this one? I integrate it. I integrate lambda of x, which is lambda naught into e power minus x by L into dx from 0 to e power minus tau d tau. All right, at a distance tau, I take a infinitesimal element d tau. 0 to x, I get mass of this into acceleration. Acceleration is f naught by integrating it from lambda naught minus tau by L d tau, integrating from 0 to L naught. This is my tension in the string at a distance x. So lambda naught gets cancelled out. So that will be f naught into e power minus tau by L naught by minus 1 by L naught by e power minus tau by L naught by minus 1 by L naught under limits 0 to L, under limits 0 to x. Minus 1 by L naught is constant, so that gets cancelled out. It comes out of the limits, this gets cancelled out. All I have to do is substitute the limits now. So f naught into e power minus x by L naught minus 1, because e power 0 is 1, divided by e power minus 1 minus 1, which is equal to 1 minus e power minus x by L naught by 1 minus 1 by e into f naught is my acceleration. Sorry, tension. So look at the tension, how it is varying. When x is equal to 0, my tension is 0. When x is equal to L, my tension should be f naught. Let us see whether we are getting the same from the equation as well. When x is equal to 0, 1 minus 1 is 0. So total tension is 0. Makes sense. When x is equal to L naught, e power minus 1, 1. So 1 minus 1 by e by 1 minus 1 by e. This gets cancelled out. I'll get f naught. That also makes complete sense. Let us plot the graph now. Okay, I'll plot it here. Do we have space? Okay. It's not by this into e power 1 minus e power x by L. When x is equal to 0, it is, when x is equal to 0, what is the value? 0. When x is equal to L, it is f naught. This doesn't matter, right? That's how it's exponentially increasing. This is my tx as a function of x. Is it clear, students? It is this function. At t equal to 0, it is 0. Oh, sorry, x is equal to 0, tx is 0. At x is equal to L naught, tx is f naught. It is very exponentially, increasing exponentially like this. Why do I draw like this? Not like this. Because my e power minus x is my parent function. So I transform this e power minus x transformation చేసి ఇలా అర్థం చేసుకోవచ్చు. If you have any doubts, I'll tell you. Otherwise, I'll go ahead. Is it clear?
Yes, sir.
Okay. Others, is it clear? Is it clear, students? If yes, I'll go ahead. If at all you have a network issue, you can type it in the chat box. Otherwise, if you can unmute and speak, you can unmute and speak. You better unmute and speak. Okay. Okay, I'll go ahead. See, this is just mathematical. All right. Physics is very simple, but it's just mathematical. So you don't have to be afraid of this thing. If we can formulate the equation, that's enough. This math, this integration and all will come with practice. But formulating an equation is very important. How do you formulate the frame the equation? How do you formulate the integral? Okay. Now look at this. I've got a lift which is going down with an acceleration a. And there is a rope here. Rope having mass m and length L. It's a linear mass density is lambda, which is constant. All right. It's a uniform rope. I have to find out the tension in the string as a function of x. All right. So what do I do? First, I choose a reference frame. I choose ground as a reference frame. There are two reference frames here. One is ground, one is lift. How to deal with lift? That we'll deal in pseudo forces. When we deal with pseudo force. But right now, false force. But right now, we are dealing with situations from the perspective of ground, like reference frame as ground. So I'll consider only all the real forces. I'll draw the FBD of this part, hanging part, X part. Tension ఇలా ఉంటుంది Px. This is mxg. From ground, I see it's going down with an acceleration a. So my equation would be mxg minus tx is equal to mx into a. Required to find a. Oh, sorry, tx. So tx is mx into g minus a. All I have to do is find mx. What is mx? Lambda into x. What is lambda? M by L into g minus a. So I'll get m into g minus a into x by L is my tension as a function of x. It's increasing linearly with x and also depends on acceleration as well. If it is going down with acceleration g, my tension is zero throughout. See, g minus a naught is there. Factor is g minus a naught. The multiplication factor is g minus a naught. So g is equal to a naught is equal to g ante this becomes zero. My tx is zero. That means tension is zero throughout. All right, that's coming under free fall. But if a naught is not equal to g, something less than g, in that case, I'll have m into g minus a into x by L, which is y is equal to mx form. So tension at x is equal to 0 is 0. Tension at x is equal to L is m into g minus a. And varies linearly like this. Is it clear, students?
Sir, sir, can you repeat?
Yeah, I can.
Third
Which
step, sir.
here is this
Third
one?
step, I don't know. No,
This
sir.
one? This
Yes,
one.
sir.
See, mx రాస్తున్నాను. What is mx? Mass of this part, hanging part. ఎలా రాస్తాను? Linear mass density into length. Because it's a uniform row, I'll write linear mass density into length will give me mass of this part. But what is
How,
linear mass
sir?
density? Okay, ఇలా చూడు. For mass m, for length L, mass is m. For length x, mass ఎంత ఉంటుంది? m into x by L కదా?
Yes, sir.
So m into x by l and m by l into x. This m by l is called linear mass density. So linear mass density అంటే ఏంటి? Per unit length అంత మాస్ ఉంది. ఇంత length కి ఎంత ఉంటుంది? Per unit length into that length will give me total mass. For particular unit length, I've got mass as m by l. For length x ఎంత ఉంటుంది? m by l into x.
Yes, sir.
So now I get linear mass density into length is by mx. mx into g minus a is by tx. Simplify చేస్తే I get some constant into x by l. x by l y is equal to mx ఫామ్ లో ఉంది. At x is equal to l చేస్తే m into g minus a వస్తుంది. At x is equal to 0 రాస్తే tension is 0. It's a linear function.
Yes,
Y is equal to
sir.
mx form. All right. Now, what if the slope is not linear, but it is varying with lambda is varying with lambda naught into e power minus x by l. అప్పుడు ఎలా చేస్తాను? This equation remains the same. This equation remains the same, right? mxg minus tx is equal to mx into a naught. So tx is equal to mx into g minus a naught.
Yes, sir.
So physics of the problem is still the same, just that formulation of integral is different. Now mx have to plug in. mx ఎలా రాస్తాను? mx is equal to integral e power minus tau by l naught d tau 0 to x.
So what is tau?
Tau in the morning also I told you, tau is a variable. ఇక్కడ ఆల్రెడీ x యూస్ చేశాను కాబట్టి ఇంకొక వేరియబుల్ తీసుకుంటున్నాను tau అని. At a distance of tau from here, I am taking d tau, element d tau. Tau is a variable, Greek letter. X, Y, Z, P, K, ఏమైనా తీసుకోవచ్చు కదా, but usually tau is taken. So I've taken tau. Tau is a Greek letter, TAU. Tau.
Okay, sir.
All right. P, Y కూడా తీసుకోవచ్చు. All right, but I've taken it as tau because you just get used to some Greek letters. All right, there's nothing new in it. You can take Y as well. If you want, I'll take Y. But for a dummy variable, usually tau is taken. It's called a dummy variable. అంటే x variable, now distance variable is x. But I need another variable to find the mass of this one. So I section this into many infinite number of infinitesimal elements, each of length infinitesimal length. That is d tau. So at a distance tau, I'm sectioning it as d tau. D tau the ఎంత ఉంటుంది mass? Lambda into d tau. Lambda ఎంత ఉంది? Lambda into e power minus tau by l into d tau. I integrate this from 0 to x, I get mx. mx into this into g minus a is my tx. All right. So let's integrate this. So lambda naught into g minus a into e power minus tau by l naught by minus 1 by l naught under limit 0 to x. ఈ మైనస్ తీసేసి x to 0 చేస్తా లిమిట్స్. So what I get is lambda naught into g minus a e power 1 minus e power minus x by l by 1 by l, which is lambda naught into l. This is my function. So this is my tension as a function of x. Is it clear? See, this is just mathematical. There's no rocket science here. ఏం లేదు. ఇది సింపుల్. F is equal to m రాసాను. ఇది చాలా సింపుల్ ఇది. ఈ ఈక్వేషన్ చాలా సింపుల్ కదా. FBD సింపుల్ ఉంది, సిచ్యువేషన్ సింపుల్ ఉంది, ఈ ఈక్వేషన్ సింపుల్ ఉంది. ఇది కాంప్లికేటెడ్ అనిపిస్తుంది. If you just do once or twice, you'll get used to it. All right. So there is not much of logic there. It's just purely mathematical. All right. Physics ఇక్కడ అయిపోయింది. Physics is very simple. But this is all mathematical. All right. ఒకసారి చేస్తే మీకు కాన్ఫిడెన్స్ వచ్చేస్తుంది. All right.
Yes, sir.
Okay. Now let's go for another one. Now let's look at this question. I've got a disk. Surface mass density of the disk is sigma naught, which is uniform. Ante, if total mass is m, sigma naught is m by pi r square. Mass per unit area.
5 నిమిషాలు.
Yeah, Bhavna, see, it is not confusing. Physics చాలా సింపుల్ ఉంది చూడు. T minus net force is equal to mass into acceleration రాశాను, రైట్? బట్ రిమైన్ వాజ్ మ్యాథమెటికల్. ఆ మ్యాథమెటిక్స్ ఏమో ఒకసారి మీరు చేస్తే కాన్ఫిడెన్స్ వచ్చేస్తుంది. సో ఇట్స్ నాట్ కన్ఫ్యూజింగ్, ఇట్స్ జస్ట్ దట్ ఇట్ ఇస్ న్యూ టు యూ. కొత్తగా ఉంది కాబట్టి అలా కనిపిస్తుంది. సరేనా భావన?
Okay, sir.
No, see, it might seem intimidating, or it might seem little difficult because you are new to it. I mean, this situation is new to you. Writing integrals is new to you. This is the first time we are applying basic math concepts to physics. This is the first time we are applying. Alright, kinematics కూడా ఇంత heavy apply చేయలేదు, exponentials మనం apply చేయలేదు, right? But here we are the first time applying integrals, basic math integrals to this one. అప్పుడు చేసిన మ్యాథ్స్ వాల్యూమ్ ఇంటిగ్రల్, సర్ఫేస్ ఇంటిగ్రల్ అవి ఇప్పుడు అప్లై చేస్తున్నాం. Alright, so it just so it is just acha, by the way, Bhavna, have you done those basic math videos?
Yes, sir.
Okay, దాంట్లో ఏం డౌట్స్ లేవా?
No, sir.
Okay, that's good. See, students, don't be afraid looking at the integrals. The thing is, you need to practice once or twice. You just write the integral, you will get confidence in writing the integral. But what is more important is not the answer. The framing of the integral, framing of the equation is important. I told you, మీరు ఈక్వేషన్ ఫ్రేమ్ చేయండి, ట్రై చేయండి, రెస్ట్ ఐ విల్ హెల్ప్ యూ. ఇదంతా ఇంటిగ్రేషన్ లో నేను చేస్తాను. లిమిట్స్ ఎలా చేయాలి, టౌ ఎందుకు తీసుకోవాలి, టౌ ఎలా తీసుకోవాలి, అవన్నీ నేను హెల్ప్ చేస్తాను. బట్ ద ఫిజిక్స్ ఆఫ్ ది ప్రాబ్లమ్ యూ ట్రై టు డూ. ఓకే, ఇక్కడ చూడండి, ఫిజిక్స్ ఎంత సింపుల్ ఉంటుంది, బట్ ద క్వశ్చన్ లుక్స్ వెరీ కాంప్లెక్స్, బట్ ద ఫిజిక్స్ ఇస్ వెరీ సింపుల్. ఓకే, సో సిగ్మా నాట్ ఉంది. సిగ్మా నాట్ ఇస్ మాస్ బై ఏరియా. మాస్ పర్ యూనిట్ ఏరియా అంటే మాస్ బై టోటల్ ఏరియా. ఏరియా ఇస్ పై ఆర్ స్క్వేర్. ఇట్స్ a very thin disk. Now what am I doing to this disk is, along this diameter, horizontal diameter, I am applying a force of F naught. All right.
Yes, sir.
Now what is required is, see, look at the question. Question looks very difficult, but physics is very simple. I'll convince you that it's very simple. Just give me 2 minutes. I'll convince you that physics is very simple. We'll solve this problem tomorrow. For today, you can relax. But look at the question is this. I have to
Sir?
find out. See, yes,
Can you tell me what is mean by sigma here?
sigma is mass per unit area, surface mass density. Mass, total mass is m, area is pi r square. So mass per unit area is m by pi r square. This is called sigma. There are three densities we have done in basic math. Lambda is one, linear mass density. Sigma is surface mass density. Rho is volume mass density. All right. So mass per unit length is lambda. Mass per unit area is sigma. Mass per unit volume is rho. All right. This is a standard notation. All right. So sigma ఏంటి? ఇప్పుడు 2 kg mass onto 2 meter square area లో అంటే sigma is 1 because 2 by 2 mass per unit area is 1. అంటే ఒక యూనిట్ ఏరియా తీసుకుంటే ఎంత మాస్ ఉంటుంది? సో if I have got 10 units of area, 10 into sigma is my total mass. ఒక యూనిట్ కి సిగ్మా ఉంది. Okay. All right, let me come back to the question. Students, we'll do this again. See, provided you interact, if you're not interacting, I'm not getting whether you're able to follow me or not. చెప్పండి ఏదైనా ప్రాబ్లం ఉంటే. All right, I'll go slow or I'll repeat, but these things are very important. These formulations, these methodologies, these strategies will chase you till 2 years. Next 2 years వరకు ఇలాంటి స్ట్రాటజీస్ చాలా వస్తాయి, ప్రతి చాప్టర్ లో వస్తాయి. ఇది కొత్త కాబట్టి ఇది కొంచెం డిఫికల్ట్ అనిపిస్తుంది. బట్ లుక్ ఎట్ ద క్వశ్చన్. క్వశ్చన్ లుక్స్ ఇంటిమిడేటింగ్. దిస్ క్వశ్చన్ లుక్స్ వెరీ డిఫికల్ట్. ఇట్స్ స్కేరీ. బట్ ప్రాసెస్ ఇస్ వెరీ సింపుల్. I'm not talking about the mathematics. I'm saying the physics of the problem is very simple. I'll tell you what the question is. The question is this. చూడండి, ఇప్పుడు ఈ సర్కిల్ డిస్క్ ఉంది కదా, ఈ డిస్క్ లో ఏ సెక్షన్ అయినా తీసుకుంటే దిస్ సెక్షన్ right part of the section is pulled by left part of the section, right? This is being pulled like this. Let's say I've got a chain. If I pull this chain here, this part is being pulled by this part kada. This right part is pulled by, left part is pulled by right part. Left part is pulled by right part. Left part is pulled by right part. Ante kada?
Yes, sir.
Similarly, if I section this like this at a distance of x, this right part is pulling this left hand side by some force. Right? ఇక్కడ టెన్షన్ అంటాము, ఇక్కడ కూడా టెన్షన్ అనొచ్చు. So this right part is pulling this left part by some force. I have to find out that force as a function of x. Question is scary. I'm telling you, question is scary. F naught is applied along the diameter. So it is moving along the diameter in space like this. It is in gravity free space. Space లో ఉంది, no gravity. Or horizontal table మీద ఉంది, ఇది ఇలా ఉంది, G ఇలా ఉంది. What does it mean? G ఇలా ఉందంటే what does it mean? It's on a horizontal table. I'm looking from above. Right? Now look at the question. Question says, find the tension at a distance x. Find the force with which this right part is pulling this one as a function of x. Alright, so చూద్దాం ఎలా చేద్దాం. So all I have to do is, I draw the FBD of both. I'll just complete the FBD and we'll leave the question for tomorrow. So I'll have T, F naught. Is it okay? So let this be mass M1, M2. So I can write T is equal to, or Tx is equal to M1 into A naught. And second equation would be F naught minus Tx is equal to M2 into A naught. Right. So what is, if I add these two equations, Tx gets cancelled out. F naught is equal to M1 plus M2 into A naught. What is M1 plus M2? M naught, mass of the disk. So my A naught is nothing but F naught by M naught. I got A naught here. I have to find Tx. I'll just take this A naught and substitute over here. But what else is required? M1 is required. For M1, I have to find the mass of this one. For that, what I need? Sigma is given, area is required. Sigma into area will give me mass M1. So physics of the problem is simple. See, ఇది ఎంత ఎన్ని టైమ్స్ చేసాం మనం, ఇది ఈ ప్రాసెస్ చాలా సార్లు చేసాం మనం. Do you all see this? సింపుల్ కదా. F minus T is equal to M into A. T is equal to M into A. రెండు ఈక్వేషన్స్ రాసాను, యాడ్ చేశాను, నాకు యాక్సెలరేషన్ వచ్చేసింది. ఆ యాక్సెలరేషన్ తీసుకెళ్ళి దీంట్లో సబ్స్టిట్యూట్ చేస్తాను, నాకు టెన్షన్ వచ్చేస్తుంది. సో ఫిజిక్స్ సింపుల్. బట్ నౌ కమ్స్ ద ఇంటిగ్రల్. ఇంటిగ్రల్ ఎలా వస్తుంది ఇక్కడ? I have to find the area of this one కదా. Let us see how do I find the area of this one. This is very interesting. Or area of any one I'll find. So physics is simple. Question is scary, but physics is simple. But what is intimidating is math. So what I do, I'll just show this one and then close the class, end the class. At a distance x, ఇది x కదా, ఇది x కదా.
Yes, sir.
So at a distance of, నాకు దీని ఏరియా కావాలి. ఎలా కనుక్కుంటాను ఏరియా? నాకు సెక్టర్ ఇస్తే సెక్టర్ ఏరియా నాకు ఫార్ములా తెలుసు. సెమీ సర్కిల్ అంటే πr స్క్వేర్ బై 2 ఉంటుంది, ఫుల్ సర్కిల్ అంటే πr స్క్వేర్ ఉంటుంది. బట్ దీని ఏరియా నాకు తెలియదు కదా, దీనికి ఫార్ములా లేదు కదా, ఇలాంటి సెక్షన్ కి ఫార్ములా లేదు కదా.
No, sir.
So in that case, you have to integrate. What I do, at a distance of tau, I section it into thin strips. of area of width d tau. Width d tau and distance tau, I've taken strip of width d tau. నేను దీని ఏరియా రాసుకొని దీన్ని ఇంటిగ్రేట్ సమ్అప్ చేస్తే అన్ని చాప్ చేస్తాను కదా, ఇన్ఫినిటెసిమల్ పీసెస్ చేస్తాను, ఇన్ఫినిట్ నెంబర్ ఆఫ్ ఇన్ఫినిటెసిమల్ పీసెస్ చేస్తాను కదా, ఐ సమ్అప్ ఆల్, ఐ గెట్ ది ఏరియా ఆఫ్ దిస్ వన్. We
Yes,
have done
sir.
such a volume integral in basic math. Such a volume integral we have done in basic math. So let's just quickly do this. This is R naught, radius of this disk. So what is the length of this one? R naught square minus tau square under root into 2, because this and this twice, into d tau is my area of this one. I sum it up. Integration is nothing but summing it up from minus R naught to x. That's it. I get the area of the required section. ఇప్పుడు ఈ ఇంటిగ్రల్ ఏంటి? ఫార్ములా ప్లగ్ ఇన్ చేస్తే ఇంటిగ్రల్ వచ్చేస్తుంది. See, my physics was very simple. Only thing is I had to find the area of this one. So area into this sigma will give me mass of this one. Mass into A naught is giving me tension Tx. All right. So this is what is intimidating. This is what is
Sir,
scary.
minus R naught in this one, sir. Limits
Correct.
low.
లిమిట్స్, రైట్. చూడండి, ఇది ఆరిజిన్ కదా నాది, టౌ ఇక్కడ నుంచి మెజర్ చేస్తున్నాను. నాకు టౌ ఎక్కడి నుంచి వెళ్ళాలి? ఇక్కడ నుంచి. నేను నా సెగ్మెంట్స్ ఇలా ఉన్నాయి. నా ఇన్ఫినిటెసిమల్ స్ట్రిప్స్ ఇలా ఉన్నాయి. ఈ స్ట్రిప్ ఎక్కడి నుంచి స్టార్ట్ అవుతుంది? ఇక్కడ నుంచి స్టార్ట్ అవుతుంది. ఈ కోఆర్డినేట్
Yes,
ఎంత?
sir.
ఈ కోఆర్డినేట్ ఎంత? మైనస్ ఆర్ నాట్ కదా,
Minus R naught.
అందుకే మైనస్ ఆర్ నాట్.
Okay, sir.
ఎక్కడి వరకు వెళ్తుంది? ఇది ఎక్స్ వరకు వెళ్తుంది. సో అప్పర్ లిమిట్
Yes,
ఇస్
sir.
ఎక్స్. అదే నాకు ఇది కావాలనుకోండి, ఈ ఏరియా కావాలి, చిన్న ఏరియా కావాలి, అప్పుడు లిమిట్స్ ఏముంటాయి? ఎక్స్ టు
R naught.
X
X
to
to
R
ఆర్
naught.
నాట్. దట్స్ రైట్.
R naught.
అంతే. ఈ ఫార్ములా మీరు మ్యాథ్స్ నేర్చుకుంటారు, బట్ ఇట్స్ జస్ట్ ఎ ఫార్ములా. ఈ ఫార్ములా ప్లగిన్ చేస్తే మనకు వచ్చేస్తుంది. సో వీఆర్ నాట్ బాదర్డ్ అబౌట్ ది ఆన్సర్ నౌ. వీఆర్ బాదర్డ్ అబౌట్ ది స్ట్రాటజీ అండ్ ద ప్రొసీజర్ వీఆర్ అడాప్టింగ్ ఫర్ న్యూ కైండ్స్ ఆఫ్ ప్రాబ్లమ్స్. Alright. So is it physics wise, is it a new problem? No. But mathematical formulation, no, it's a problem. It is new to us. This procedure is new to us. But physics wise, it is an old problem. F on the T on the mass on the F minus T is equal to M into A, T into T is equal to M into A. Ante simple F is equal to M rasanu. FBD F is equal to M. Ronde chesanu. Now physics అయిపోయింది అక్కడ. You give this to any math student, so physics of the problem is done. As a physics class, it is over. Physics student అయిపోయింది problem. So problem is not difficult. Problem is scary because we are new to this method. So confusing లేదు, but it is scary because it's new to the method. ఒకసారి మీరు చేస్తే you will develop confidence. All right. So students will continue tomorrow. So don't worry about integrals రావట్లేదు అంటే don't worry. But we have to get used to it. All right. We have to get trained to tackle such problems. They are not difficult. They are just new to us. ఇది కొత్తగా ఉన్నాయి కాబట్టి అలా అనిపిస్తున్నాయి, టఫ్ అనిపిస్తున్నాయి. But they are not tough. I'm telling you, these are not tough. Even if you feel tough, they are just because you are new to this. That's it. All right, students.
Yes, sir.
Yes, sir.
All right. So see you tomorrow. Bye, everyone. Good night and good luck.
Thank you, sir.
Bye-bye.
Thank you.
Most welcome. Bye.